Hello and welcome to this video on predicting FIFA player ratings using machine learning. In this video, we'll use the FIFA players 2015 to 2023 dataset from Kaggle to explore how we can apply machine learning techniques to real-world data and make accurate predictions. The first step in any machine learning project is to load the data into a suitable programming environment. For this project, we'll use Python as a programming language and Pandas as a library for data manipulation and analysis. Pandas allow us to read CSV files and store them as data frames. We can use the following code to load the dataset into a variable called df. The next step is to perform some pre-processing on this dataset to make it suitable for modeling. This includes handling missing variables, encoding categorical variables, if any, and scaling numerical attributes. We'll discuss the reasons as we go on. Handling missing values. Missing values are a common issue in real-world data and they can affect the performance and accuracy of our machine learning models. There are different ways to handle missing values, such as deleting rows or columns with missing values, replacing them with mean or median values, or using more sophisticated methods such as imputation or interpolation. For this project, we'll use a simple approach of deleting rows with missing values since our dataset is large enough and we don't want to introduce any bias or noise by filling in the gaps. The drop any method takes no arguments or inputs and returns a new data frame without any missing values. We can use the following code to drop rows with missing values from our data frame. Encoding categorical variables. Categorical variables are variables that have a finite number of possible values, such as gender, nationality, or position. Machine learning models usually require numerical output, so we need to encode categorical variables into number before we can use them for modeling. There are different ways to encode categorical variables, such as label encoding or one-hot encoding. Label encoding assigns a unique integer to each category, while one-hot encoding creates a binary vector for each category, with one element being 1 and the rest being 0. For this project, we'll use one-hot encoding for categorical variables since it avoids the problem of ordinality that the label encoding may introduce. Ordinality means some categories may be considered more or less important than the others based on their numerical values, which may not reflect the true nature of the data. We can use the following code to perform one-hot encoding on the categorical variables in our data frame. Scaling numerical attributes. Numerical attributes are variables that have continuous or discrete numerical values such as age, height, or overall rating. Machine learning models may be sensitive to the scale or range of the numerical attributes, and they may perform better if the attributes are normalized or standardized. Normalization means scaling the attributes to a range between 0 and 1, while standardization means scaling the attributes to have a mean of 0 and a standard deviation of 1. For this project, we'll use standardization for numerical attributes since it preserves the distribution of the data and reduces the effects of the outlier. We can use the following code to perform standardization on the numerical attributes in our data frame. Visualization. The next step is to create some visualizations to illustrate the relationship between certain attributes and player ratings. Visualizations can help us understand the data better and identify patterns or trends that may be useful for modeling. For this project, we'll use matplotlib and seaborn as our libraries for creating plots in Python. Matplotlib is a low-level library that provides basic functionality for creating plots, while seaborn is a high-level library that provides more advanced features and aesthetics for creating plot. We'll create two types of plot: scatter plots and regression plots. Scatter plots show the distribution of two variables on a Cartesian plane, while regression plots show the linear relationship between the two variables along with a confidence interval. We'll create scatter plots and regression plots for the three pairs of variables: overall ratings versus age, overall ratings versus potential ratings, and overall ratings versus values. We can use the following code to create these plots. From these plots, we can observe some interesting insights. There is a negative correlation between overall rating and age, meaning as a player gets older, their ratings tend to decrease. This makes sense as the players lose their abilities and mental abilities as they age. There is a positive correlation between overall rating and potential rating, meaning as the players have higher potential rating, their overall ratings tend to increase. This makes sense as players with higher potential may have more room for improvement and development. There is a positive correlation between overall ratings and values, meaning as a player have a higher overall rating, their values tend to increase. This makes sense as players with higher values may be more in demand and more valuable in the transfer market. Regression and classification. The next question is whether predicting the overall rating is a regression or a classification problem. Regression is a type of supervised learning where the goal is to predict a continuous numerical output, while classification is a type of supervised learning where the goal is to predict a discrete categorical output. For this project, predicting the overall rating is a regression problem since the output is a continuous one, which ranges from 0 to 100. We can use regression models such as linear regression, ridge regression, or random forest regression to predict the overall rating based on the input attributes. Model selection. The final step is to select a suitable model for a regression problem. There are many factors that can influence the model section, such as the size and complexity of the data, the performance and accuracy of the model, and the interpretability and explainability of the model. For this project, we'll use random forest regression as a model of choice. Random forest regression is an ensemble learning method that combines multiple decision trees to create a more robust and accurate model. Random forest regression has many advantages over other methods, which we won't discuss. We'll just directly skip to the code. Here you can see the code on the screen. The code does the following step. It imports the train test split function from the sklearn.model selection module, the random forest regressive class from the sklearn.ensemble module, and the mean squared error function from the sklearn.metrics module. These are the functions and classes that the code will use later. It splits the data into train and test set using the train test split functions. It trains a random forest regression model on the train using the random forest regressor class and their fit method. The random forest regressor class takes some parameters such as n estimators, max depth, and random state as argument and returns a model object. It makes predictions on the test set using the predict method of the model object. The predict method takes the x test array as an argument and returns an array of predicted values y_pred. It evaluates the model performance using the mean squared error function from the sklearn.metrics module. The mean squared error is a common metric for regression models that measures how close the predicted values are to the actual values. It is calculated by taking the average of the square differences between y_pred and y_test. The lower the mean squared error, the better the model performance. The code prints out the mean squared error using a formatted string. Thus, in this video, we have learned how to predict FIFA. For watching this video. See you guys later.